All right, dear students, in this video lecture, I'll be discussing projectile motion. And projectile motion is a very important topic at higher secondary level in physics. So it is important for every student that he or she must have a good understanding of projectile motion. Now, projectile motion is a motion in which two coordinates change. That means a projectile motion is equivalent to a two-dimensional motion. Now the question is, what is a two-dimensional motion? A two-dimensional motion is a motion in which both x as well as y coordinates of a moving body change. That means if something is going like this, I call this x, I call this y, then this body is executing a two-dimensional motion. That means at any point on this curve, x is changing as well as y is changing. So the point is that if both the coordinates x as well as y change while a body is in motion, we call this motion as two-dimensional motion. And the fact of the matter is that this two-dimensional motion is equivalent to two one-dimensional motions. That means if we have to discuss a problem in which both the dimensions x as well as y changes, then we are directly talking about a two-dimensional motion. And we can discuss this motion, we can understand this motion by independently discussing the motion along x and the motion along y. So, we are already aware about one-dimensional motion, and we understand the equations of motion in one dimension. S is ut plus 1/2 of at square. This equation gives us displacement. Another equation is v is equal to u plus at. This equation gives us velocity. And the third one is v square minus u square is equal to 2as. Now, if we are in the domain of a two-dimensional motion, then these equations are equally valid. These equations are valid along x, and in the same situation, these equations are valid along y. So, what we say that a two-dimensional motion is equivalent to two one-dimensional motions. That means if we discuss one-dimensional motion in two directions, we are discussing two-dimensional motion. Now, for the sake of argument, if I have to write down these equations along x, so the same set of equations, we can write along x and we can write along y. That means if I have to write the equation of displacement, x is equal to uxt plus 1/2 of axt square. This will be the displacement of the particle or a body along the x-axis. Now the displacement along the y will be uy plus 1/2 of a y t square. Now you see, these two equations, this equation and this equation, they are both the equations of displacement. But this equation is giving me the measurement of displacement along x-axis. And this equation is giving me the measurement of displacement along y-axis. Similarly, here ux is a representation of initial velocity along x-axis. Ax is the representation of acceleration along x-axis. Uy is the velocity along y-axis, the initial velocity along y-axis, and ay is the acceleration along y-axis. Similarly, the other two equations can be written in terms of the coordinates. The other two equations can also be written. Suppose I write Vx. Now Vx will be equal to ux plus axt. Along y, Vy will be equal to uy plus ayt. And I can write down Vx square minus ux square is equal to 2ax x. Now this x is displacement along x-axis, and this x is signifying the fact that this acceleration is along x-axis. Ux is the initial velocity along x-axis, and Vx is the final velocity along y-axis. In the similar way, we can write here Vy square minus uy square is equal to twice ayy. Now this y is the displacement along y-axis. It is that s that we have in one-dimensional motion. Similarly, this x is the displacement along x-axis. It is the same s, but this displacement is along x-axis. So one point is clear here, that in two-dimensional motion, when we talk about two-dimensional motion, this two-dimensional motion is always equivalent to two one-dimensional motions. And the fact of the matter is, in case of two-dimensional motion, both x as well as y coordinates change. So in order to understand, in order to learn the dynamics that involves two-dimensional motion, what is important is that we should resolve these equations. We should resolve these vectors along x-axis and along y-axis. So we can write down these equations along x-axis. I can write down the equations of motion along x-axis in this fashion. I can write down the equations of motion along y-axis along y direction, the motion along y. So this will be the basic funda that will be used to derive certain expressions that signify the predictions of projectile motion. So these equations will be playing an important role. And the matter of the fact is that a two-dimensional motion is always equivalent to two one-dimensional motions. Now the question is, what is projectile motion? What is projectile motion? Suppose a body is thrown like this. A body is projected like this, and it takes certain course in air under the influence of gravity. Now we can see that this motion of a ball, of a bullet, of anything that is thrown with some velocity, in this motion, x is changing, as well as y is changing. So at the first I should say that this motion is a two-dimensional motion. That should be the first thing that I should assign to this kind of thing. Why it is a two-dimensional motion? Because in this motion the x-coordinate is changing, also the y-coordinate is changing. Now the point is that this motion is executed in such a way that your role is simply that the body must have some initial velocity. There is a body that has been thrown from this origin with some initial velocity. So this body is moving under the influence of gravity alone. The gravitational force is acting on it. There is no other force acting on this body. If you have a situation in which you threw a body is thrown in space with respect to Earth, and it moves in the space only under the influence of gravity of the Earth, we call this motion as projectile motion. Now the examples of projectile motion are simply if a ball is thrown, somebody is on the ground, a ball is thrown in air. The motion that it executes, this motion is a projectile motion. And the body that has been thrown in air, that body is referred as projectile. So the body that you threw in air, that's called projectile. And the motion that it executes under the influence of gravitational force, that motion is called as projectile motion. And the only force that acts on this projectile during the course of its motion, the only force that acts on this projectile is gravitational force. And this gravitational force is always directed towards the center of the earth. It's always directed towards the ground. Now, the next important point for this projectile motion is that this acceleration due to gravity, its component is only vertical in nature. Acceleration due to gravity is acting in this direction. It is acting in this direction, but it is not at all acting in horizontal direction. There is nothing that is attracting this projectile along x-axis. But along y-axis, this projectile is under the influence of acceleration due to gravity, is under the influence of gravity of the earth. So this must be the most important point. That when you have a projectile, you throw it in the air, the force that acts on this projectile is the gravitational force. And the direction of that gravitational force is always downwards. So its acceleration keeps on changing in the vertical direction. At the same time, there is nothing that is attracting this projectile towards horizontal, that is attracting this projectile towards x-axis. Therefore, I should say the acceleration of this projectile along the horizontal is 0. So these are the two important points that have to be kept in mind. That this projectile is moving under the influence of gravity. It's moving under the influence of gravity of Earth, and the direction of gravity is always vertical in nature in the present situation. Now the second important thing is the velocity. Now see, vertically the acceleration is changing, okay? It's going to change from here to here. Similarly, the vertical velocity is going to change. That means Vy, if I say Vy is the vertical velocity, it's going to change. It will have different values at different points. And I can say, if this is the maximum height of the projectile will not move anything in vertical at this point. At this point, this Vy must be 0. Other than this point, there is a value for Vy at every point on this projectile. At the same time, the velocity along x-axis, since the acceleration along the x-axis is 0, that means the velocity along x-axis should be a constant. It should be a constant. That means if I talk about the velocity along x-axis at any point, its value must be same. It's not going to change because there is no acceleration along the horizontal. 0 itself is a constant. There is no acceleration along x-axis. Therefore, the velocity component along the x-axis of this projectile is always a constant. So, if I summarize the things in a very simple manner, I will say anything that is thrown in air with respect to ground is called a projectile. And if this object moves only under the influence of gravity of the Earth, then the motion that this body has executed is called as projectile motion. The examples of projectile motion there can be a variety of examples. A ball thrown in air, it's a projectile motion. An airplane moving in air and leaving a bomb, the bomb will fall under the influence of gravitational force and all. So that bomb has projectile motion. So projectile motion, if I have to speak in a very, very simplest way, I will say anything that moves in the influence of gravity alone, changing its x as well as y. The motion that has been executed by this body is called as projectile motion. In projectile motion, there is change in vertical acceleration, but there is no horizontal acceleration at all. The vertical component of velocity keeps on changing, and its value is 0 at the maximum height, but the horizontal component of velocity remains same throughout the motion of the projectile. So as we have already talked about projectile motion, if you have a projectile, and if we threw this projectile from some height, then this kind of motion, the motion this projectile will execute, this kind of motion is called as horizontal projection of projectile. Now the point is that you already have a projectile at some height, and this projectile is shot in air and it moves under the influence of gravity alone. Now we want to make certain calculations, we want to achieve certain results that can be used to make certain predictions, to make certain calculations. Now, as all of you know, that a projectile motion is a two-dimensional motion. And a two-dimensional motion is always equivalent to two one-dimensional motions. So I can resolve this motion into two motions. One motion is along x-axis and another motion is along y-axis. But before proceeding, we can see that we are projecting this projectile from this point with some velocity u. And you can see that the initial velocity of this projectile has only one component at this height, and that component is x component. You can see there is no vertical component of initial velocity at this point. So I should say that the vertical initial velocity at this point from where the projectile is shot is 0. So I can say that we have ux as initial velocity with which this projectile is shot. Now if I take the horizontal component of displacement, horizontal component of displacement. Now, what is horizontal displacement in this case? I can write the original equation is s is equal to ut plus 1/2 of at square. So instead of s, I will write x is equal to ux t plus 1/2 of ax t square. Now, we know that whenever we have a projectile motion, the horizontal acceleration is always 0 because there is nothing that is attracting this projectile horizontally. That means I will say that ax is equal to 0. And ux, okay, ux can be treated as u because uy is 0. So what this equation will boil down to, what I will get from here is horizontal displacement. This horizontal displacement x must be equal to ut. Alright. Now, let us write down the vertical component of displacement. Write down the vertical component. Vertical component of displacement. What will be the vertical component of this displacement? That will be y is equal to uyt plus 1/2 of at square. Now this a is ay, it's not a basically, because the acceleration should be along y-axis. We are writing down the displacement along vertical, along y-axis. As all of you know, this uy is 0 because there is no initial vertical velocity. So uy must be 0. And this ay, since the ball is going down, it's going down, as a convention, we take value of acceleration due to gravity as negative. So ay is minus g. And this y, because the height is decreasing, the displacement is decreasing, we also take the convention for y as minus y. Okay, when we do these substitutions, we will substitute these things in the vertical displacement, in this vertical displacement. What will we get? We will get minus y is equal to, okay, this term is 0 because uy is 0, minus 1/2 of g because ay is equal to g t square. I hope this is clear. I hope you understand it. So this minus and minus will cancel out. I can use the value of t in this equation from this equation. I will merge the two equations. So what will I get? I will get y is equal to 1/2 of g. Instead of t square, I will write x square divided by u square. Okay. Now this is an equation that is giving a correlation between y and x. And you can see in this equation 1/2 is a constant, acceleration due to gravity for the particular problem is constant, and initial velocity with which this projectile is shot is also constant. What does that mean? That means this y is directly proportional to x square. Y is directly proportional to x square. So I can write y is equal to kx square. While k is a constant, and this k is equal to how much? This k is equal to 1/2 of g upon u square. Now the point of contention is that this equation is called equation of parabola of first order. That means the projectile that has been shot from this point in horizontal direction will have a trajectory. It will have a path. That trajectory will be same as that of parabola. That's why this trajectory means the path, the total path taken by the projectile from the point of initiation to the point where it hits the ground, that path is called as trajectory of the projectile. And this equation tells me that the trajectory of the projectile is parabolic, because this is the equation of parabola of first order. Okay, so the first thing is clear that the trajectory, the path this projectile will take will be parabolic in geometrical sense. Now, let's go with some more expressions that we have to achieve from this subject. Now, the first thing, that how much time this projectile will take from the point where from it has been thrown to the point it hits the ground. This time, this total time is known as time of flight. Is known as time of flight. How much time the projectile will take? A projectile is shot from some height with some initial velocity. What time it will take to hit the ground? That time is called as time of flight. Now, if I write down the horizontal equation for final velocity, suppose I write Vy. Vy is equal to Uy plus AT. AYT. Okay, I'm writing the velocity in vertical direction in this case. And my intention is to calculate the time of flight. And what is time of flight? Time of flight is total time taken by the projectile from the point of projection to the point where it hits the ground. That's called as time of flight. Now this Vy is the final velocity. Okay, so we have already obtained an expression between the horizontal displacement and vertical displacement, in which we found that y is directly proportional to x square, and that equation is an equation of parabola of first order. That means the trajectory that this projectile will follow will be a parabolic trajectory. Now, there is another important thing that we would like to evaluate is the time of flight. And time of flight means how much time this projectile will take to move from the point of projection to the point while it hits the ground. This time, this total time refers to the time of flight of a projectile. So in doing so, in evaluating this thing, we will write the vertical displacement of projectile. So what is vertical displacement here? Vertical displacement, that is y is equal to uy t plus 1/2 of ay t square. Now you can see in this case initial vertical velocity is 0, so I will say uy is 0. In this case, ay is the acceleration. All of you know that in projectile motion, there exists only vertical acceleration. And for the sake of sign convention, since this projectile is going down, this ay is taken as minus g. Now y? What is y? Y is, if I replace this vertical displacement y by the height from where the projectile is shot, this y should also be taken as minus h as a convention, because the displacement is decreasing as the projectile goes down. That's why we take a convention for y equal to minus h. So in doing so, that means the problem that you have been writing here, the equation that you have been writing here, you have tried to boil down this equation to the total height. Now this total height refers to the total time taken by the projectile to reach the ground. Therefore, from this equation, the t, that is t at any instant, this t can be replaced by capital T. And this capital T is called as time of flight. It gives us the measure of time of flight. That means how much time this projectile will take from the point of its projection to the point while it hits the ground. Now, what we have to do is we will use these formulations in this equation. Okay? So instead of y, what should I write? I should write minus h is equal to uy is 0, so this term is gone. 1/2 is okay. Instead of ay, what should I write? Minus g. So minus I will write outside. This will be g. T square. This t refers to time of flight now. So here I will write t square. Now from here, this minus and minus will be removed. So we will get t square is equal to 2h divided by g. This t, that is time of flight, will be under root of 2h divided by g. This is the expression that's required to measure the time of flight. When you shoot a projectile from the point in horizontal direction and it falls alone in gravity. Now, what this equation tells us? This equation tells us that the time of flight is dependent on the height. It depends on the height where from you have shot this projectile horizontally. And it does not depend on the mass of this body. That means if I have two bodies projected from the same height with same initial velocity, they will reach the ground at the same instant of time. This is what it means, because the time of period is independent of the mass of the projectile. It does not depend on the mass of the projectile. So if you shoot two projectiles in air having different masses, And assuming that there is no air resistance, the air resistance is 0. The two projectiles with two different masses, maybe one mass is 1 kilogram, another mass is 5 kilogram. You shoot them with the same velocity, horizontally, they will reach the ground at the same interval of time. That means their time of flight will be same. Now moving on, we have calculated the time of flight. The next important thing that we would like to discuss is the range. Range. Now what's the meaning of range? We generally have heard things like, this person has a gun, what's the range? This country has a missile, what's the range? So range is the total horizontal displacement that this projectile takes. The total displacement that the projectile has along horizontal is referred as horizontal range. Now, that means we are interested to calculate x. So, to calculate x, what is the horizontal component of x? What is the horizontal displacement? What is the horizontal displacement? The horizontal displacement is x. And that is equal to what? That is equal to uxt plus 1/2 of axt square. Now you see, in this case, x, when you will calculate the total horizontal distance, this x must be replaced by the range. So that range is symbolized as r. This ux, it is constant, it remains constant throughout the motion of the projectile. So this ux is simply u. And what about ax? All of you know, there is no horizontal acceleration. This ax is equal to 0. So, x will refer to the range provided this t is the time of flight. Because time of flight is the total time taken by the projectile from the point of its projection to the point it hits the ground. That means this x will be called as range of the horizontal range of the projectile, provided this t is equal to time of flight. That's capital T. So we can calculate, we can write down the equation for the range, horizontal range. So in this case, instead of x, I will write r is equal to, instead of ux, I will write u, instead of t, I will write capital T. What is capital T? Capital T is the time of flight. And we have already evaluated the expression for time of flight. And what is that expression? T is equal to 2h by g under root. So the range of this, the horizontal range of this projectile will be r is equal to u under root of 2h divided by g. Now see, the same conclusion is coming here, that the range of a projectile does not depend on its mass. It does not depend on the mass of the projectile. You bring two objects. One object has a mass of 10 kilos, another object has a mass of 100 kilograms. Okay? Shoot them with the same initial velocity from some height. They will acquire the same horizontal range. That means they will hit the ground at same point. They will take the same time. Their ranges will be same. Their ranges will not differ, even if their masses are different. So this is the expression for the range. So what is range? Range is the total horizontal displacement of a projectile. Is referred as horizontal range. Now, let us calculate velocity at any instant of time. That means, suppose at this point I want to calculate the velocity. Now, at this point, you will have two components of velocity. One will be Vx and another will be Vy. And Vx and Vy, they are a component of some velocity v, which this projectile will have at this point. And let us suppose that this velocity vector makes an angle beta with the horizontal. Now, the point of contention is that I want to calculate the velocity of this projectile at any instant of time during its motion. So what can I do for that? If I write vertical component of velocity as Vy is equal to Uy plus Ayt. Now what is this Uy? All of you know this Uy is 0. And what is this A of y? A of y is minus g. Alright? So what will be Vy? Vy will be, it will be minus gt. What about Vx? Horizontal component of velocity. Vx will be ux plus axt. So, all of you know that ax is 0. There is no horizontal acceleration. And ux is simply u. So what will be Vx? As predicted, Vx is u. Now, this is the vertical component of this velocity vector at this point, and this is the horizontal component of this velocity vector. So, what is the resultant velocity from parallelogram law of vectors? Since these two components are very perpendicular to each other, what will be the resultant velocity? Resultant velocity. What will be that? Resultant velocity, I will call that v. That will be under root of vy square plus vx square. Of course, it is vx square plus vy square plus twice vx vy cos theta. But theta as a whole here is 90 degree. So cos 90 is 0. That's why the resultant velocity will be under root of vy square plus vx square. So instead of vy, what should I write? I should write minus gt. So this is under root of minus gt whole square plus, instead of vx, I should write u square. So the resultant velocity at any instant during the projectile motion, that is v, must be equal to under root of u square plus g square t square. Alright. At the same point of time, we would like to calculate the angle that this resultant velocity makes with the horizontal. The angle that it makes. So this is your resultant velocity. So if I write down tan beta, that is perpendicular by base. What is perpendicular? That's Vy. Divided by what is the base? Base is Vx. So what is tan beta? Tan beta is, instead of y, what I have gt. If I take its magnitude, it is gt. Divide by what is Vx? That's u. So beta, the angle that this velocity vector makes with its horizontal component, beta, will be tan inverse of gt divided by u. This should be the case. So what have we done? We have discussed what a projectile motion is. We started with the concept of two-dimensional motion. We found that projectile motion is a two-dimensional motion. Then what we did after that, we said that a two-dimensional motion is equivalent to two one-dimensional motions. All right. Then we tried to learn the dynamics of projectile motion, and we observed that there is only vertical acceleration in projectile motion. The horizontal acceleration is 0, and the horizontal velocity is constant throughout the motion of the projectile. Then what we did, we obtained a result that says that the trajectory of this projectile is parabolic in nature, and we calculated the time of flight, the total time taken by the projectile to hit the ground from the point of its projection. That came out to be t is under root of 2h by g. Then we calculated the horizontal range. The horizontal range is the total horizontal distance covered by a projectile. We obtained the result of range, and that range is u under root of 2h by g. Then after that, what we did is we calculated the velocity of this projectile. We obtained an expression to calculate the velocity of this projectile at any point in the space, and that expression came out to be v is equal to under root of g square t square plus u square. And finally, what we did, we calculated the angle, that the angle this velocity vector at any instant of time makes with the horizontal, and that angle comes out to be beta is equal to tan inverse gt by u. I hope this lecture will give you some kind of feast that you feel that you can get out of it. We are this time living in a time of turmoil, because virus is spreading very fast. And my request to all of the students out there is that they should make sure that they make use of SOPs, they use mask when they are for any kind of work outside, and take care of their family members, and follow the instructions that the government is giving from time to time. Thank you.